Hi there, this is Mr. Wolf. Today we'll be doing geometry, benchmark number 1, define terms. A couple of things to go over here before we start the actual content. Always take detailed notes in your math binder. Okay, remember we can summarize by making things shorter. We can paraphrase, put things in our own words, but some things we need to quote, write down exactly as it is, like formulas and definitions. You can pause, rewind, play at your own convenience. Just learn at your own speed as long as you're learning. Be an independent, active learner. If you don't understand something, figure out the solution. We've got Khan Academy, and you can just Google the standard. The standard is G.co.1. I had it listed here, and I'll list it on each video. And if you just Google that standard, you'll come up with something like this that'll explain it in more detail, and you can actually find a lot of information that'll help you. Don't procrastinate watching the videos. Sometimes your life gets busy and you don't want to wait too long. Things happen. If you'd like, you can subscribe to my YouTube page and make it a little easier on yourself. And of course, as always, if you have any questions or problems, email me, text me. You can even reply to this video down below, and I'll get that notification as well. So just let me know what's going on to help you. Okay, let's get into the content. First off, we need to define some undefinable terms, which sounds kind of odd, but these are the three basic terms that make up geometry: points, lines, and planes. I'd like you to pause here and copy down these definitions. Feel free to summarize as needed. So points, you could think of like the pixels on your television screen. You get real close to your television screen and you can see those little dots. But actually, in geometry, points you could never see. They're infinitely small. Points are really just a location. And if we stream together an infinite amount of points in a row, what do we get? Well, we get a line. Okay? So points make up a line. There's no spaces between those points that make up the line. Okay, so here's some examples of some lines and how we actually label and identify them. First off, points are always identified by capital letters. So you'll see here we have points A, B, and C. Okay, and over here we have some points that are on a line, and we actually use points to name a line. So we can call this line any 2 points that are on the line. This line would be line DE, or we could call it line ED. Either way is fine. Or we could call it line FD. These are all referring to the same line. And there's other combos too that would work: EF, DF, and so forth. We can also refer to a line or name a line with an italicized lowercase letter, if that is given. In this case it is right here, and this line would just be called line A. So we got a couple different ways to call a line with either 2 points or a lowercase italicized letter. The term collinear, if you break that down into 2 words, we end up with co and linear. Co means together and linear means on a line. So these 3 points here are all collinear. Please write down the definition for collinear. Okay, here we're asked to give 6 different names for the line that contains points U, V, and W. I'm going to show you the answers, so pause right now. And here are the answers. 6 different ways to call this line: UV, VW, UW, and so forth. Okay? Whenever lines intersect, they intersect at a single point. In this case, that point is called K. Jot down this postulate: 2 lines intersect at exactly 1 point. Here's an example. It says name 3 points that are collinear. Well, we could say A, D, and C are collinear because they all exist on the same line. We could not say B, D, and A are collinear because they aren't all on the same line. Name 3 sets of points that are non-collinear. Well, as you might have guessed, non-collinear means they are not on the same line. So my example I just gave would work. B, D, and A are non-collinear. What is the intersection of the two lines? It is this point right here, point D. Here are your answers as well. Next, we need to define a ray. A ray is similar to a line, but lines go on in both directions forever. Okay, and that's why we see an arrowhead on this side and an arrowhead on this side. But a ray has an endpoint on one side and an arrowhead on the other. A ray goes in one direction infinitely and ends at the other. An easy way to think about this would be sun rays. They originate at the sun and then they shoot straight out forever. We call a line AB by putting a line with two arrowheads on top. But we call a ray AB with a line with one arrow on top. A small difference, but it makes a big difference. Okay, and this goes over how to name rays. So this is ray AB. We always put the letter of the endpoint first here. Okay, so A is where it starts, and you can see that A is lined up with the endpoint. B is where it continues on forever, and so you can see B is lined up with the arrowhead. Down here it goes the other way, and so we flip the letters. B is on the endpoint, and that's why it's here. And A is on the end that goes on infinitely. Opposite rays are two rays that share a common endpoint. Okay, and it says that right here. All of these definitions you should be writing down. Okay, so here we've got a couple different rays. We've got ray CA, which would go this way. Whoops. Let's get a pen. Ray CA goes this way. Ray CB goes this way. And these are opposite rays because they share endpoint C. Collinear rays are rays that exist on the same line. So we could say ray CA, which starts here and goes that way. We could say ray BA, and they exist on the same line, and that's why we call them collinear. Here's a couple examples. Name a point that is collinear with the given points. R and P, well here is, let me find my highlighter, right there. R and P. So one other point on that line would be point M. Okay. If we look at M and Q, it asks for a point that is collinear with those. We would say point T. You do the other two on your own. Next, let's jump to our third undefined term. We've already dealt with points and lines, and now we're at planes. It's important to note the difference between these three, and I'm going to jump right back here to make it clear. Points have no dimension. Lines have one dimension. Planes have two dimensions. And later on this semester we'll get into three-dimensional figures. But for now, let's just take note that planes only have two dimensions. Here we are. Okay, so copy down these notes on planes. This flat surface here is a plane. A plane is a flat surface that extends in each direction forever. So imagine a piece of paper that just goes in all directions forever, and that would be a plane. In order to name a plane, we use any three non-collinear points. Okay, so for example, we could call this plane KLM. So think about this for a second. When we did when we did points, they were named by one capital letter. When we did lines, they were named by two capital letters. And now we're doing planes, and they're named by three capital letters. Any three, as long as they're in the same plane and they're non-collinear. Okay, this gives examples of points that are collinear on the same line. We wouldn't use those to name the plane. J, G, and K are all collinear, and only one of those points is on the plane, G. F, G, and H are all on the same plane. However, they are collinear, so we won't use those. J, G, and H are three non-collinear points, but J is not on the plane. Okay, so it's important to note that we need 3 non-collinear points on the plane. So for example, plane FGI. Sometimes planes intersect. Here's a visual of 2 planes intersecting. You might also think about the corner of a room where 2 walls meet. When 2 planes intersect, what is formed is a line. In this case, that line is called AB. Here's an example of some other planes. Through any 3 non-collinear points, there's exactly 1 plane. So if you name any 3 points that exist, it could be the corner of your desk, and the corner of your chair, and a point on the ceiling. There is 1 plane that will go through all 3 points. Name the following points. A point not in plane HIE. We can see that plane HIE is this plane right here. What's a point that is not on that plane? You guessed it, it's G. Let me remove that. A point not in plane GIE. Plane GIE would be this plane here. And we can see that H is not in that plane. You may answer the other questions on your own. Next definition is a line segment. We've already done lines, which go on forever, and we've done rays, which go on infinitely in one direction. Line segments end at both endpoints. So if, in this case, we have endpoint A, we have endpoint B, and so we call a line segment segment AB. You'll notice that the top has no arrowheads. That tells us that it ends. Please copy down this information. The ruler postulate tells us that on a number line, every point can be paired with a number, and every number can be paired with a point. This is pretty simple, and you've been doing this most of your life. Just setting up a number line, and we can identify each point with a number. We take the absolute value when calculating distance because you can't ever move a negative distance. So the distance from A to F is 6 minus negative 8, or the absolute value of negative 8 minus 6, which would be 14. Again, we never have a negative distance, so that's why we always take the absolute value. If we wanted to know the distance from B to C, we could do one of 2 things. We could count the spaces, 1, 2, 3, or we could take the absolute value of negative 5 minus negative 2, and we would get 3. Parallel lines are lines that lie in the same plane and are the same distance apart over their entire length. They never intersect. The segment addition postulate tells us that if we take one segment, for example AB, and we add it to another segment, for example BC, we get a larger segment, AC. This should be pretty obvious, but please write down the term segment addition postulate, as we will return to this term throughout the year. In Algebra 1, you visited the distance formula. The distance formula is just the Pythagorean theorem rearranged. Let me show you. Here we're looking for the distance of A to B. And they've set up a triangle. We know from the Pythagorean theorem that a squared plus b squared equals c squared. Please copy down the distance formula, which looks like this. And if you look at it, you see that really we're doing the same thing. This would be a squared, this would be b squared, and once we add those together, we square root it to find the length of the hypotenuse. Copy down the distance formula, please. Here it is again. Just recall, we subtract the x's, square it, subtract the y's, square it, add those 2 together, and then square root. Here's an example if you'd like to try it. You can pause here, and now I'll show the answers. There's your answers. And now we're at the midpoint formula. The midpoint is the point right in the middle on a line segment. To calculate the midpoint formula, we take the average of the x's and the average of the y's. That would look something like this. This is the midpoint formula, and it's crucial that you copy this down. Add the x's, divide by 2. Add the y's, divide by 2. Okay, so in the example here, we would add 2 plus 10 because 2 is an x, and 10 is an x. We divide it by 2. We get 6. Next, we do the same to the y's. Add 4 and 6, which gives us 10. Divide by 2, which gives us 5. Our new point for our midpoint would be 6, 5. Endpoint formula. Sometimes we're given one endpoint and one midpoint, and we must find the other endpoint. We have two methods to do that. One involves using this formula. If you use this formula, you must do it for x and y. M stands for midpoint. What is our mid-x? It is 4. What is our endpoint? E stands for endpoint x. It's -2. So we would do 2 times 4 minus a -2. That's 8 minus a -2. And remember, when we minus a negative, it's adding. And when we add those together, we get 10. That was for the x's. You have to do the same thing for the y's. The midpoint y is 10. And the endpoint y is -4. 20 plus 4. 24. So our point is 10, comma, 24. Okay? Another way to do that is simply by counting. How far is it from -2 to 4? Well, we went up 6. So we need to go up 6 more from our 4, and we end up at 10. How far is it from -4 to 10? From -4 to 10, we go up 14. So we add 14 onto 10, and we end up at 24. You'll see that we get the same answer either way we do it. Both are good methods. This brings us to the end of our first lesson. I'm sorry this one went a little over 15 minutes. In the future, I'll try to teach a little bit quicker. If you didn't get everything, please pause, go back, capture your notes, and let me know if you have any issues at all. Thank you. See you in class.